Hello, everybody. Welcome back to this is video part four. Part four of um, all this study guide. I just misplaced my pen. There is the other. Okay, we'll just use this one here. So let's take a look at our next problem. The figure shows a spinner with 8 congruent sectors in the xy plane. The origin and 3 points are labeled if the coordinates of x are -5 halves, comma, -5 root 3 over 2. What is the measure of angle XOB? So we are looking for XOB, which is this angle right here. And we know the coordinates of x are -5 halves, comma, -5 root 3 over 2. Okay. If the coordinates of x are this, what the measure? So, if you recall that the coordinates of any point on a circle centered at the origin are always going to be r cosine theta, comma, r sine theta. This will answer this expression right here will answer so many questions for you guys. Okay, so we know that r is 5. So that means that this is going to be 5 cosine theta, comma, 5 sine theta. And so the point on this circle is going to be 5 times whatever the cosine value is. So we just got to factor a 5 out of here. So this is, we could just factor in 5 out of all of this. And so this is -1/2, comma, negative root 3 over 2. So the angle from in standard position, so this angle right here, that is going to match -1/2, negative root 3 over 2, which on our unit circle, I would show you guys my unit circle, but my keyboard is now down because I spilt sweet tea everywhere, and the unit circle kind of went down with it a little bit, so it's kind of hideous. But the -1/2, negative root 3 over 2, is at 4 pi over 3. So that this orange angle is 4 pi over 3. And we want to find the measure of this pink angle right here. And so this pink angle is going to be half the circle plus whatever that extra bit is. So if we take the entire bit here, subtract this half, it should be fine. So we're going to take 4 pi over 3, and we will subtract half the circle, which is pi. So pi is half the circle, and we will make that, 3 pi. We'll make that 3 pi over 3. So pi is 3 pi over 3, so they have common denominators. I subtract them. 4 pi minus 3 pi is pi over 3. So that should be the angle of this spot right here. Pi over 3, which is B. Number 19. The function f. The function f is defined by f of x equals a sine, yep, that's the whole transformation mode, or the standard form, this transformation form. For constants a, b, c, and d in the xy plane, the points 2, 2, and 4, 4 represent a minimum and maximum value on the graph. What are the values of a and d? So a is amplitude, d is midline. Both of these can be obtained with min and maxes. Min and max. Amplitude is equal to max, minus minimum divided by 2, and then D is equal to max plus minimum divided by 2. And since the max is 4, the minimum is 2. This is 4 minus 2 over 2. And this is going to be 4 plus 2 over 2. So 4 minus 2 over 2 that's just 2 over 2, which is 1. This is 6 over 2, which should be 3. So we should have an A of 1 and a D of 3 right there. Okay, this one says we need a calculator. So let's get out our calculator here. Okay, the function f is given by 2 sine 4x plus cosine of 2x. So these are two different angles, so we'll have to keep track of that. Using the period f, which of the following is the number of cycles of the graph between 0 and 1,000? Oh, wow, okay. So we need to figure out the period of f of x. So it says we can use a calculator, so I guess the first thing we're going to do is punch that into here. Oh, I guess looks like I already worked on it on this one, so let's see what we got. So that's what, 2 cosine 4x plus cosine of 2x. We'll hit graph. And we get this right here. Okay, so I guess we need to figure out the period of that. So if we're going to figure out the period, one thing we can do is, let's see, we can figure out from a max to a max. So one thing we can do is go to calculate. So there's a blue label here that's calculate. Hit second calc. Find the maximum. That's number 4. And there's a lot of maximums to find. So if I get where it's on a glare, there's a lot of maximums to find. So here we could set an interval. So I'm going to find this maximum right there first. So I'll put one line to the left of the maximum and then hit one line again to the right of the maximum. And you probably hear my dog out there getting upset about something. So now there is a maximum between these two in this interval. And if we hit enter, we should get a maximum at, so we have maximum at 2.73. So this is going to be 0.3520 something. Great. And now we need one more maximum. So we'll do it again. And the next maximum occurs over here. So I'll put one line to the left of it, one line to the right, and then hit enter again. And it should give me another one. I have another maximum that occurs at 3.4936. So these are two x values for the maximum. I subtract these two. So second quit. I will subtract these two. We get 3.4936 about minus 0.3520. And we get 3.1416. So with some rounding errors, this is about pi. It's probably exactly pi, but we're not really sure. So we know how many times will this function repeat from 0 all the way to 1,000. So that's pretty much times, like how many, so we have this big section right here. Put it right here. And how many chunks of pi will happen in between here. So let's just do 1,000 divided by pi. And so hopefully get 318. So hopefully 318 is an option. It is B. So 1,000 times divided by the period, which is equal to 1,000 divided by pi, which is about 318. So we should have 318 repetitions. Awesome. Okay. Yeah, one cycle per pi, and there are 318 pi's in 1,000. 21. The function h models a periodic phenomenon. The maximum of h is 8, which occurs at time equals 0. So I have some point here, and it is 0, 8, and it's a maximum. This is a max. The period of h is 12 hours. So it repeats every 12 hours. So then we would also have, what, 12, 8 would be another one. Over here again should be 24, 8. And all this is said is a periodic phenomenon. It hasn't said it's a sine wave, so we don't know. We just know that this happens. Which of the following could be an expression for h? Okay, so they did use sine and cosine here. Okay, so since this is a max at 0, so that is a max at 0, that tells us that we're going to use cosine. So that will take care of A and B. Next up, what else can I tell from this? We have a max of 8. Oh, the period. Our period is going to be equal to 2 pi over B. Oh, I need B, not period. So let's go B is equal to 2 pi over period. And my period is 12. Yep, period is 12. So this is going to be 2 pi over 12. So my B should be pi over 6. And so I have pi over 12 and pi over 6. So that should give me D. D. We cannot figure out amplitude. We cannot figure out midline from just this information, but we can figure out period, which is what's different. Okay, let's check out the next page. Put one more page on here. 22. The figure shows the graph of a trigonometric function f. Which of the following could be an expression for f? So let's see here. I'm looking here. All our a's are the same. All of our b's are the same. All of our d's are the same. So this is just talking about phase shifts. So it looks like it's just talking about phase shifts. So let's take a look here. So right now so the first two are positive cosine. So for positive cosine, this peak right here would have to be right here. Would have to be at the y-intercept. So what is the distance from here to there? So that peak from there to there is pi over 2. So pi over 2, I do not see a pi over 2 here. So it's probably not pi over 2. So let's try sine. For sine to work, we would have to go by the midline. This does have, so the midline is 1, so, or negative 1. So this right here, y equals negative 1 is our midline. And so I need this point here to be on the y-axis. So for us to use sine, so this part is cosine. For us to use positive sine, I need increasing at the midline to be at the y-intercept. So let's see here. This is pi over 2. This should be pi over 4. So do I have a pi? Oh, I have a pi over 4 here and a pi over 4 here. So this should be, so it's not the cosines. It has to be C. Has to be C. Okay, the function f is given by f of x equals 2 cosine of that. The graph f is mapped to the graph of g in the same plane. Okay, so we have two functions, f and g. F of x is this equation here. And g, we don't know. Oh, g is the same, but the same as f, but it's it's pi over 2 units to the right. Okay, so 2 cosine. This is what, pi x. So b is pi put x right here, plus 0, plus 3. So this is f of x. And g of x is essentially the same thing. We are probably going to just use 2 cosine pi, and then now we need to, oh, actually, this should be negative 0. We'll make that negative 0 so it fits. Now, this tells us that c is pi over 2. So c is equal to pi over 2, and we're going to the right. So it should be a positive pi over 2. So if I take a positive pi over 2 and plug it in here, this is naturally a negative c, so the positive is just going to leave that the same, plus 3. So I should have 2 cosine pi, and then x minus, and this will be x minus pi over 2. Because we're going to the right, that should be a minus, which it goes backwards. So it's not C or D, because that has nothing inside the parentheses. So it's going to be B. It's going to be B. There we go. Okay, moving on here. The function of k is given by k of theta is equal to 2 sine theta. What are all the values of theta for 0 between theta and 2 pi, where k is equal to negative 1? Okay, so we need to find out all the times when, so let's see here, k of theta is equal to 2 sine theta. So that tells us that it's going to be some sine function here. Our amplitude is 2, so this max will be 2. This will be some value 2, and this will be some value negative 2, because that's our amplitude. And we are going from 0, so this is going to be through the midline here. That should be our y-axis. And 1 repetition, so that's about right here. That's 1 period, and that's 2 periods. The period here is, what it looks like, is just going to be 2 pi. Period is 2 pi because we don't have any b, so it's going to be 2 pi over 1. B is 1, 2 pi over 1. So this should be 2 pi, and this is going to be no amplitude, no midline shift, so this is just going to be 0, 0. And there's our rough sketch of a graph. And we want to know how many times does it equal negative 1. So there is a spot here. This is y equals negative 1. And so we need to figure out these values right here. What are the x values there and there, right? So when I plug some stuff in, we're going to do a little bit of algebra here. If k of theta equals negative 1, then I can say negative 1 is equal to 2 sine of theta. Now, let's get theta by itself. We're trying to figure out what theta is. So I can divide both sides by 2. Negative 1/2 is equal to sine theta. So now I just need to get my T-stained unit circle. Here it is, the beautiful T-stained unit circle. And we need to figure out when does sine equal negative 1/2. Well, sine's our y value. Y value negative is down here at the bottom. Negative 1/2 is going to be 7 pi over 6 and 11 pi over 6. So I should get 7 pi over 6 and 11 pi over 6. Here they are, right here, D. There we go. Okay. This one, I guess you didn't really need the entire picture. You could have just done it right here. I like to sketch the picture and try and get an idea of what I'm looking at, but sometimes you can skip it and just go right here, and that is plenty. Okay, guys, I will see y'all in part 5.